Hello everyone, welcome to this third video on Chebyshev's inequality. We have been trying to apply the Chebyshev's inequality to solve problems for which the probability function is not known, but just we know about the quantities like mean and variance. We use it to find an upper or lower bound for a given question. The question over here is a discrete random variable takes the values -1, 0, 1 with probability 1 by 8, 3 by 4 and 1 by 8 respectively. We will have to evaluate probability of x minus mu greater than or equal to 2 sigma, and you will have to compare it with the upper bound which has been given by Chebyshev's inequality. So the problem as such consists of two cases or two parts. One is we will have to estimate the actual values, and now the second part is estimate the Chebyshev's values. Since the data is going to be given with the correct probability, both the accurate answer can be obtained using the actuals as well as the approximate answers can be obtained using your Chebyshev's inequality. We'll compare both of them and see if they are going to deviate by a greater value or a smaller value or they perfectly coincide. Now coming to the question. What is the question asked? The question is going to be find probability of modulus of x minus mu greater than or equal to 2 times of sigma. First, we will try to find the answer by Chebyshev's inequality, and then we will move on to go with the actuals. Out of the two Chebyshev's inequality format which we have, which one will suit this given question more aptly? We will have to check for that first. So the two formats are x minus mu greater than k sigma and the other one is x minus mu less than k sigma. Compare it with the given question x minus mu greater than or equal to 2 sigma. So now this matches more perfectly x minus mu greater than or equal to 2 sigma and k sigma. So this matches more perfectly. So we are considering the first format probability of x minus mu greater than or equal to k sigma less than or equal to 1 by k square. Now comparing with the quantity which is available over here. Okay, what can you say about the quantity called as k? K is equal to 2. And hence, by Chebyshev's inequality, the given question will obviously be less than or equal to what is in your right hand side? 1 by k square. So this is going to be 1 by 2 square. And hence, you have it as 1 by 4. Therefore, by Chebyshev's inequality, the probability of modulus of x minus mu greater than or equal to 2 sigma is less than or equal to 1 by 4. This is my answer using Chebyshev. Now we will take the other part of the question, which is computing it in the actual way. So this answer which you have obtained is going to be my approximate solution. So what is going to be the accurate solution? We will have to check for it. So now moving on to accurate solution, or you call it as actuals. What do we know about the random variable x? The random variable x takes the value -1, 0, 1. It takes the value -1, 0, 1 with the probability of x being, what is the probability? 1 by 8, 3 by 4, 1 by 8. 1 by 8, 3 by 4 and 1 by 8. We want the probability of modulus of x minus mu greater than or equal to 2 times sigma. So I need what is mu? I need to know what is sigma from the given data. The mu stands for the mean value which is given by E of x. The formula for E of x is summation x into probability of x. So this gives me -1 into 1 by 8 plus 0 into 3 by 4 plus 1 into 1 by 8. 0 into something vanishes and this gives me -1 by 8 and positive 1 by 8. Adding up leaves you with 0. So from here I have the quantity called mu as 0. Next moving on to sigma, standard deviation. The standard deviation is given by root over variance of x. And what is going to be my variance of x? It is e of x square minus e of x the whole square. Now already we have e of x, so let us compute e of x square. The formula is summation x square into probability of x. So that gives us as minus 1 the whole square into 1 by 8, 0 square into 3 by 4 plus 1 square into 1 by 8. 0 into something vanishes. Minus 1 the whole square makes it as 1 into 1 by 8. So it is 1 by 8. Plus 1 square is 1 into 1 by 8. It is 1 by 8. So this is going to be 2 by 8, which can be reduced as 1 by 4. So this is my e of x square. So having got e of x square, what will be our variance of x? It is e of x square minus e of x the whole square. The value for e of x square was 1 by 4 minus what was the value we obtained for e of x? It was 0. So we have variance of x to be equal to 1 by 4. That is sigma square is 1 by 4. So the standard deviation sigma is the positive square root of your 1 by 4. So when I take positive square root of 1 by 4, you have it to be equal to 1 by 2. So I have my mu to be equal to 0 from over here and my sigma to be equal to 1 by 2 from over here. Now go and apply it to the required quantity. The required quantity is probability of x minus mu greater than or equal to 2 sigma. And this will now give me probability of x minus 0 greater than or equal to 2 times of sigma is 1 by 2. Hence, I have this as probability of modulus of x greater than or equal to 1. I need to estimate probability of x greater than or equal to 1. The value taken by x are minus 1, 0, 1 and the corresponding probability of x are 1 by 8, 3 by 4 and 1 by 8. Now let us analyze this part. What is modulus of x less than or equal to a? When I have modulus of x less than or equal to a, my value varies between minus a to plus a. So my region over here will be to the negative minus and to the positive a. So it will vary between minus a to plus a. This is when I have less than or equal to inequality. When I have modulus of x greater than or equal to a, where will it vary? So this is my minus a, this is my plus a, this is minus infinity and this is plus infinity. In which case the value of greater than a will vary between a to infinity to the positive side and minus a to infinity to the negative side. Okay, so I have greater than or equal to means moving towards infinity and minus infinity. Now considering our case, I want modulus of x greater than or equal to 1. So in the line number, this is going to be minus 1, this is going to be plus 1. I want the portion between where to where? I want it from 1 to infinity and minus 1 to minus infinity. This is going to be inclusive of 1 and minus 1. So inclusive of 1 and minus 1. So what is going to be the value over here? This can be represented as probability of x equal to 1, which is going to be the only value which can be taken by x, because x doesn't take any value beyond this. And what is the only value which can be taken towards your left hand side? It is probability of x equal to minus 1. So when it is going to be greater than or equal to 1, it can take either the value 1 or it can take the value minus 1. Beyond it, there is no definition or the probability defined for x. Now what is this probability of x equal to 1? Probability of x equal to 1 is 1 by 8. And what is probability of x equal to minus 1? It is also 1 by 8. So 1 by 8 plus 1 by 8 makes it as 2 by 8. So the answer is 1 by 4. So I have the actuals of x minus mu greater than or equal to 2 sigma to be equal to 1 by 4. And I can see that by Chebyshev's inequality also, the answer happens to be less than or equal to 1 by 4. So this inequality, which is less than or equal to 1 by 4, which was got using the Chebyshev's value, actually coincides with the actual values of x minus mu greater than or equal to 2 sigma equal to 1 by 4. There is also one more way in which this quantity can be approached. If you are not comfortable using this minus a to minus infinity and a to infinity, go for the negation of it. What will be the negation of probability of modulus of x greater than or equal to 1? You can write it as 1 minus probability of modulus of x strictly less than 1. So this becomes 1 minus probability of minus 1 less than x less than 1. It is strictly less, so no equality over here. What is the number between minus 1 to 1? Not inclusive. The value between minus 1 to 1 not inclusive is just x equal to 0. So it is 1 minus probability of x equal to 0. What is probability of x equal to 0? It is going to be 3 by 4. So if I substitute the value as 3 by 4, you can have the answer as 1 by 4. So either you can work it out in this way, taking the complement of the action, or you can work it out using the direct method and get your answers. Thank you.